Okay, good day. This is Math 140 College Algebra. I am Professor McCully. This is lesson 1.2 graphing functions. Let's get right to it. Today we're going to talk about graphing functions, and we're going to sketch the graphs of equations by hand and with technology, and we're going to use these graphs to solve some application problems. So first thing, we can sketch graphs by plotting points, and what we normally will do with that is we will make a table of values and plot some points, and then we will connect those points with a continuous curve or a line. And I want to make sure that we understand that this method does have some flaws. If we consider the function f of x equals 1 over x, we will have what's called a vertical asymptote, and we will have to address the results of that here later, but we will have to consider domain and range issues, which we will talk about in later videos. And then we are also going to consider a library of common graphs and transformations later on as well. So let's talk about a simple example. If we want to complete a table and sketch the graph, what we can do is we can plot a few points here and make a decision about what the graph of this thing looks like. And again, I've picked some points purposely to try and show you some of the issues that may occur with this particular method. And so if we talk about y equals x squared minus 4x, if we plug in 0, well, clearly, if I use 0, 0 squared is 0, minus 4 times 0, I get 0 minus 0, well, that's just going to be 0. If I plug in 1, 1 squared is 1, minus 4 times 1, I'll get 1 minus 4, and that'll give me negative 3. If I plug in 2, 2 times or 2 squared is 4, and then 4 times 2 is 8, and so I get 4 minus 8 is negative 4. If I do 3, 3 squared is 9, 3 times 4 is 12, so I get 9 minus 12 will be negative 3. And then if we go 4 squared is 16, and then 4 times 4 is also 16. 16 minus 16 is 0. So if we do this particular graph here, and I plot the points on that, and let's see here, I need my math buttons. Let's get a graph here. Let's do a Cartesian graph. I like that. And let's bring this down right here. And if I move this down just a little bit, extend the page. Oops, didn't want to do that. I want to do this. Move this up here so we can see the points. Move that up a little bit. Okay, there we go. So now if we plot these points, at 0 I have 0, if at 1 I have negative 3, at 2 I have negative 4, at 3 I have negative 3, and then at 4 I have 0. We have this graph. And now I want to connect the dots with a continuous curve. And if you remember from your Algebra 2, you will see that this is a parabola, and we have indeed graphed those points. The intercepts of a graph, an x-intercept is where the x or the graph crosses the x-axis, and the y-coordinate is 0. And the y-intercept is where the graph crosses the y-axis, and the x-coordinate is 0. Now, if we go back to this graph right here that we just did, and we talk about x-intercepts. We talk about x-intercepts first. Any point that is on the x-axis has a y value of 0. This value right here is 2, 0. This point right here is 3, 0. This point right here is 5, 0. And so every point on the x-axis, its y value is 0. And we can leverage that power to figure out what our x-intercepts are going to be. Similarly, on the y-axis, every point on the y-axis, these 2 points just as examples, negative 4, 0, And oops, I did that. I screwed that up. So let's make sure we do it correctly here. It's 0, -4, and this point here is 0, -5. Every point on the y-axis has an x value of 0. And so again, we can leverage that fact to figure out what our y-intercepts are. So as an elementary example here, this is a linear equation. We can find the x and the y-intercepts of this particular function by leveraging the fact that if I want to find the y-intercept, what I'm going to end up doing is I'm going to let x equal to 0. And if I do that, I'll have 3 times 0 minus 4y equals to 12. And 3 times 0 cancels out. And so I have -4y equals to 12. And if I do that, then if I divide both sides by -4, I get y equaling to -3. That means my y-intercept is going to be at 0, -3. I can do the same thing to find my x-intercept. All right, I'm going to let, in this case, y equal to 0. And so if I go 3 times x minus 4 times 0, and I let that equal to 12, well, that 4 times 0 cancels out. I get 3x equaling to 12. And if I divide both sides by 3, I'll get x equal to 4. So my x-intercept here is going to be 4, 0. And we could plot those and connect the dots if we wanted to. Using technology to graph an equation, we can rewrite the equation so that y is isolated on the left. That is one way to write if we're going to use a graphing calculator. We're going to enter the equation into the graphing utility, and then we're going to determine an appropriate viewing window, and then we're going to graph the function. So if I look at bring up my, oops, I gotta bring this up, close that. If we bring up my graphing calculator here, and I have something in there, and I just want to clear that out. All right, so just to kind of review the graphing calculator as we go through. If you want to graph a function, you hit your y equals, and you get this graph here. If you have one of the Super TI-84 plus CE versions, you get a bunch of different colors, and we can graph up to 9 different functions at a time, although it gets kind of messy if you do decide to do that. But let's say what we want to do is we just want to type in a simple function. And so I'm going to hit my X button, and we'll go X plus 3. That's a simple linear equation. And if I hit graph, I get this graph. And just as a quick review, since we're starting off a new semester here, this particular standard window goes from -10 to +10 on the x-axis, and -10 to +10 on the y-axis. All right, and each of these individual values goes up by a value of 1. So if I said I went up here, I went up, and I would see that this point right here is approximately 1, 4, and I think it turns out to be okay. Now, if you hit this window button, you can change those dimensions to anything that you want, and we can just edit them. So if I wanted to make it even wider, I could go from -20 to +20, and if you hit the graph, you'll see something that looks like that, and you'll notice that there are a lot more tick marks along the x-axis here. There's a lot more tick marks because we have the window actually is the same size, but we're trying to graph more values on it, and so the window here, each tick mark is worth 1, and they're getting smaller. They're getting smaller. So if I change it to, let's say, -100 to +100, like that, if we look at the graph, we get all these itty-bitty little tick marks here, and we can't really see anything. So one thing that you can do to change that is you can change the scale. And if I change my scale and I go by tens, well, now I see, now it goes back, but I have to keep in mind that each one of these little tick marks is now worth 10, while each one of these tick marks is still along the y-axis worth a scale of 1. All right, so let's go and do an example here. Use technology to graph the function, and use technology to find the x and the y intercepts. Well, this thing right here is not in y equals form. So we have to solve for y. All right. And so the first thing I want to do is I'm going to subtract 3x from both sides. So negative 4y equals negative 3x plus 12. And then I'm going to divide both sides by negative 4. 3 equals, or y equals, and then if I go negative 3 divided by negative 4, negative divided by negative is going to be a positive. And then 3 over 4 doesn't go evenly, so I'm just going to make it 3/4 x. And then negative 4 divided into 12 will give me negative 3. And so now this is my particular function. And so I can go to my y equals here, and you notice I still have all of this messed up, these messed up values on my window. What I can do is if I hit the zoom button and I hit the 6 button for zoom standard, that will set it back to the default values. And if you look, you'll see it goes from negative 10 to positive 10 and from negative 10 to positive 10. So I can hit my y equals. And now we're going to type in this function that we just wrote here. And I don't know why I keep getting these extra dotted things, and I apologize for that. But we'll just endeavor to press on. And so I get y equals 3/4 x minus negative 3, or minus 3. And so we want to type that in. Now there's a couple ways you can type in fractions. Also, just as a manner of housekeeping here, I can clear out whatever I want just by hitting the clear button. We can start over, which is kind of nice. And so we could just make it as a separate value inside parentheses. If I go 3 divided by 4, that is one way to add in a fraction if we wanted to. Or we could go alpha and then y equals, and then we bring up the fraction menu. If I hit 1, I can bring up a fraction there, and I can go 3, bring it down there, use the down arrow key to hit a 4, hit the right arrow key to bring it up, and now I can do the x. And then I think if I remember correctly, it's minus 3. I almost put minus 4, so I'm going to put minus 3 in there. And we're going to hit graph, and here we see that standard window. All right, and it also says use technology to find the x and the y intercepts. Well, again, what we're going to do here to find those things, and we already know what they are. We already know that the y-intercept is 0, negative 3, and we know that the x-intercept is 4, 0. Well, but if we want to do technology to do that, we can use this trace button. Now, in college algebra, hitting the trace button by itself is almost never going to be good enough. What we're going to have to do is we're going to hit the second button, and then we're going to hit that trace button. It's going to bring up this calculate menu. And there's a lot of really cool stuff in here. And these first 5 we're going to use quite a bit in college algebra. These last 2 are calculus expressions, and we won't get to them. So if you get to calculus, you may get to see those. But to find x and y intercepts, we're going to find the value and the 0. Now I'm going to use the value function here to find my y-intercept, because what this function does is it allows you to type in any x value that you want along the visible x-axis, and it will tell you what it is. And we know that the y-intercept has an x value of 0. So if I type in 0 into the value, I get 0, negative 3. And as I said, we already knew that it was 0, negative 3. So my y-intercept, let's get the right tool, y-intercept is going to be 0, negative 3. And if you remember from your regular algebra class, this is in y equals mx plus b form, and the b value is the y-intercept, so we could have read it from there as well. If I want to do the x-intercept, and again, we know that it should be 4, 0. And we can see if we go 1, 2, 3, 4, it looks like it's going to cross at 4, 0. But we can use that calculate expression again, once again, to do it. So if I hit trace here and I find 0, all right, this thing finds zeros of the function. So another term for the 0 is x-intercept. So when I hit 2, it's going to say left bound. So I'm trying to find an x-intercept, a 0 of the function. And what I'm going to do is I'm going to set up a little interval where the graphing calculator can find that 0, where it actually touches the x-axis. So I'm going to use my arrow keys here. I'm going to move my little, and I call him my spider guy because he looks like a little spider crawling along a web. I'm going to hit that a couple times until I get close to where I think it's going to cross the x-axis. I'm going to hit enter, and you'll see this little triangle here, and if you have a color graphing calculator, you'll see this dotted angle or dotted line, and what it's going to do is this is the leftmost point that it's going to check for the 0. Now it says right bound here, so I'm going to move my little arrow key here till I'm a little bit on the right hand side of where I think that 0 is going to be. I'm going to hit enter. Now it says guess. Now you don't have to guess. But what that means is it wants you to push it back to about where you think it is. But if you leave it where you were at, it'll be just fine. You hit enter, and clearly 4, 0, we see that our x-intercept is 4, 0. All right. Now, let's say graph the following function using technology and determine any x and y intercepts. So now we have this division here, this division expression. We have y equals 2x over x minus 3. Now the good news is it's already in y equals form, and so we don't have to worry about that so much. We don't have to shift any functions around. We can just type it in as is. And so I'm going to go back to my graphing calculator. I'm going to hit the y equals. I'm going to clear this out. Since it is a fraction, I'm going to hit that alpha button. I'm going to hit the y equals to bring up the fraction menu. I'm going to hit 1 to have a fraction there. And then on the top, I'm going to type in 2x. So we're going to go 2x, and then I'm going to bring that value down here, and we're going to go x minus 3. And so we're going to type x. We're going to hit that minus button. We're going to hit the 3. And just to be safe, we're going to hit second. Or not second, I'm sorry, we're just going to hit the zoom button, and then we're going to hit the 6 button, and we see this graph here. And notice we have this little gap right here around x equals 3. And as we move forward, we're going to see this a few more times. And when x is 3, I get 6 on the top, but I get 3 minus 3 is 0. So when, oops, I don't want to do that. When x equals negative 3, or positive 3, excuse me, x equals positive 3, there is a division by 0. Oops, I don't know what's happening with my pen tool today. And when you have a division by 0, that's an issue. That is undefined. And that can be a problem. All right, and that's going to be an issue that we're going to have to deal with as we move on. We're not going to address it just today, but you do have to know that it's out there. But we can still use technology to determine any x and y intercepts if we wanted to. And we'll do the same process. When we want to find an x-intercept, we let the y value equal, or looking for the y value to equal 0. And we want to find the y-intercepts, we let x equal to 0. But when we see this first one right here, we'll notice that we have a 0 right there. It looks like that is the only intercept, and it looks like it's at the origin. And so we can verify that a couple different ways. We can go second, we can hit that trace button. We can find a value, and if I hit 1 and I type in 0 again, because anytime you cross the y-axis, you'll have an x value of 0. When you hit enter, we hit x equals 0 and y equals 0. So our x and y intercept in this case is at the origin. 0, 0. Well, that's all I have for this one today, folks. So, the Marvel fun fact of the day: during the filming of Avengers: Age of Ultron, Scarlett Johansson was pregnant. She needed 4 stunt doubles to help hide her belly. That's all I got. Have a good day.